From the late 1940s up to this time, we have witnessed an incredible transformation in the size of computers, shrinking from room-sized machines, like the first generational set of computers, to portable and powerful devices that we can now move around with. This evolution in size reduction has been made possible through research, unlocking new materials like silicon that made it possible to shrink the size of the major components of our devices without compromising their performance. However, since silicon, which has been used for decades to fabricate our electronic component of our devices, is approaching its physical limit, which means any attempt to reduce the size of silicon-based devices will compromise the efficiency and the performance of our devices. Hence, for the sake of prosperity, we are seeking for an alternative to replace silicon in the future. Among the list of potential materials is carbon nanotubes. Carbon nanotubes is 10,000 times smaller than a human hair, with exceptional electronic properties beyond silicon, which means replacing silicon with carbon nanotube will not only make our devices smaller, but increase the performance compared to what we have today. However, there's the challenge. Carbon nanotubes, when produced, are produced as a mixture of different types of carbon nanotubes. Some behave like metals, some behave like the semiconductors, which is often preferred for developing our devices. Hence, to unleash the potential, we have to separate the pure semiconductor carbon nanotubes. However, this is very difficult, and all known technique requires sophisticated and expensive equipment, which means large scale will be very difficult because it is expensive to carry on with. This is the area my research is currently working to address. I'm working on a simple two-step technique with low-cost method that will initiate separation of carbon nanotubes using polymers. This step is called conjugated polymer extraction because it uses polymer to form two phases where we can find our desired choice of nanotubes at the top phase, which we can further obtain using our membrane. This is a simple step that requires no technical and difficult techniques. Thank you.
Thank you very much.